Hello and welcome back, and in this video we're going to be talking about HStack, or otherwise known as horizontal stack. So horizontal stack is basically used to lay out your content in a horizontal manner. So basically opposite to vertical stack, where the child views are laid out as vertically, horizontal basically layout works on the horizontal line, and that actually gives you an opportunity to lay out your views in a horizontal manner. So let me go ahead and show you what we are talking about and how we can actually create a basic HStack. So if you start typing HStack, you're gonna see a couple of options. First of all, you have an HStack that can be created without any parameters, because it has most of the defaults. And the other one, so this one is a struct, this one is the initializer that we're gonna actually create. If I select this and hit enter, you're gonna see that we actually get the HStack, and it has this content trailing closure, which is another parameter, but we can actually simplify this further by just creating an HStack and starting and stopping curly braces. Okay, now let's talk about how the views are laid out. So I'm going to actually lay out some of the views. Alright, so as you can see, we have three different text views going on here, and if you notice that the layout of these text views in the preview window, it is actually laid out in horizontal manner. So that's what HStack does. It basically takes its child views and put them in a horizontal line. Okay, now if if your text grows in size, or you run out of the real estate on the screen, you can always put them inside, put the HStack inside a scroll view and make the content scrollable. All right, so that's how basically you can make a horizontally scrollable view. And if you wanna if you need something vertically scrollable, you can put it in a vertical stack or VStack. Now, just like any other container, any properties that you apply onto the container view, it is gonna be it'll be applied on the rest of the subviews, and we can actually see that here with the HStack as well. If we change the font to title, all the title or the font size for all the subviews changes as well. Okay, now let's go ahead and set the foreground style as well. So we're gonna set the foreground style to orange, and let's put a gradient to that, and all the text views are gonna basically adapt to that change. Okay, so that's how you create your basic HStack. Now, if you notice that there is a difference in basically the spacing part for the HStack, basically with the views. It's not so much apparent with Learn iOS with DevTechie, but if you notice that with .com, it is a little bit. So it's applying the standard spacing that actually is by default defined for the HStack, and you can see what all values are already defined by default. If you start typing HStack, and as soon as the autocomplete opens up, notice the grayed out items. Grayed out items are the items that have a default value associated with them. They are not required to create basically the HStack or that particular instance of that particular struct, because they already have a predefined value. There is an opportunity for you to override those, and that's what we're gonna see. But basically, let's talk, before we actually look into how to override, let's talk about what's the difference between this grayed out and this lit up more bright parameter, in this case content. Now this means that the content is the only parameter that is required to implement the HStack, and content is basically a trailing closure. You can see that right here. That means you can actually replace the word content in, like, all the parentheses and stuff with a simple trailing closure, just like we did basically. So instead of having this, you can actually change it to simplify like this, which is exactly same as having the other way, which is basically having the content and the curly braces. All right, now how do you override basically these values? Because they already have a predefined value, you don't have to define it, but whenever you want to override these values, you simply start typing for, like, for the value that you want to override. For example, let's talk about the alignment. If we want to override the alignment, we can actually simply override it by saying alignment needs to be top. Okay, and you can do something similar for the spacing and say we need spacing to be 0. And notice what happens here. So you have learn iOS with, and proper spacing is applied here. But now there is no spacing between with and devtechie, because those two are different views, and so is the devtechie.com. Devtechie and .com, they don't have any spacing in between, so they actually look like more part of the same string if you just look at this part right here. Okay, so that's how you can override spacing. Now you can actually override to say not 0, but like you can say you need more spacing between the elements, and then it becomes, like, a little bit more apparent, like, how the gap between subviews are, like, basically the spacing between subviews are. Okay, now with the spacing being applied, it actually gives us an opportunity to explore what else we can do with HStack. For example, we want to apply an alignment, earlier without spacing we could not see the alignment basically taking effect, but with spacing being applied and with, like, we have a view which is larger than all the other views, we can actually see the effect of alignment. So let me go ahead and apply the alignment, and I'll show you what I'm talking about. So whenever you actually create a HStack only takes as much space as it needs to render its content, and because text view is of the similar nature where it only takes as much space as needed, that means that view is contained within, like, its bounds, where, like, the content is rendered and no extra space has been taken. Now this is quite opposite of, like, other some of the other views. For example, shape views, which are, like, they're basically, they take the entire screen and as much space needed, not needed actually, as much space as possible. All right, let me show you the difference. So I'm going to take all this example out and simply put a rectangle instead in this place, and rectangle, you're gonna notice, will fill up the entire screen except the safe area, and that is because safe area is limited. You have to actually you have to specify that you want to ignore safe area, and that's when, like, the rendering engine will ignore the safe area. Otherwise, it'll actually just keep the views inside the safe area bounds. Okay, but notice that, like, rectangle takes all the space needed, but if you put a text here and draw a border around it, you're going to notice that the border of the text, which actually represents the bound of the text, it is, like, near to where, like, the text is. Basically, it's only, that means that it's only taking the space it needs to render the content. Now same goes with the HStack only takes the space that it needs to render the content. Now, whenever we change the alignment, for example, whenever we change the alignment, if your text does not have enough room, for example, if I put body, now it does not have any room to basically move around, and we can actually see that by drawing a border here. Now, even if you apply the alignment, your text, because it is within these bounds that are created for them, and they can render themselves just fine, applying the alignment will not take any effect. Okay, but if you have an item that is bigger, or basically some shape that actually takes more space, in those cases, basically, let me take this out. In this case, because you have your text bound, or your HStack bound is actually now bigger. Actually, let me put the border back so you can see, and then we'll take it out because it looks a little bit odd. So as you can see now, our HStack's bound have increased, and if I change the alignment from top to bottom, you would see our view basically changing its alignment as well. Okay, so basically HStack, you need to define a view that is actually bigger in order to see the effect of the alignments. Okay, now let's go and remove this, and we are going to check out what other options we have for the alignment. So we have center, which is the default. Top is basically aligns everything at the top of the view, and then you have bottom, which actually aligns everything to the bottom of the view, which is basically this container view. And you have a couple of other options like first text baseline, okay, and last text baseline. All right, so first text baseline, let's go ahead and try that one out first. Okay, so what we're gonna do is we are going to change all these to title size so they're bigger. Okay, and we're gonna say change this to first text baseline. Now, as soon as we change the alignment to first text baseline, notice that these iOS with and techie from dev is actually going beyond this line, and they are actually all aligned to the same line. Now, what first text baseline does is it looks at the first text, wherever that first line, bottom of the first text is ending, it actually aligns all the views along that line basically. So if you had a really long view with multiple lines, for example, this line will become really big. Okay, so for example, this line is very big. Notice the behavior of .com. .com is still aligned to the very first text, which is actually the learn iOS and dev. Okay, so that's what first text baseline alignment does. It basically aligns according to where the first text, basically the topmost text, its bottom is. Okay, now opposite to that is last text baseline, and what last text baseline does, it looks at the last text inside the view, and it basically finds its bottom and aligns everything that is there, all the child views, according to that last text baseline. Okay, so that's the difference between first text and last text baseline. Now there's one more topic that we want to discuss basically about the HStack before we wrap up this video, and it is layout priority. Okay, so layout priority is a modifier that actually defines the priority for the view and how it is going to be laid out. Okay, so what happens is whenever you create these subviews inside any container, they all get a default layout priority, which is 0, which is like, same for all the views. Now what layout priority dictates is whatever is your main view is, and the most important view that you don't want to either break into 2 lines or truncate it, you can actually up level its layout priority, and that will help with the display of that element. For example, our dev.key is being broken into 2 lines, and let's say we don't like it. We just say layout priority for this one is going to be 1. That means no matter what, the layout for the dev.key is always gonna take the precedence. So this is gonna be computed as first item for its bound that it needs, or the area that it needs to render itself, and then all the other views will basically adjust between them to make sure they provide the available space to dev.key so it can actually lays out properly. It can be laid out properly. Okay. Now just like this, you can change the layout priority for several others. Now if you change the layout priority for all the subviews as the same level, they all basically take the same precedence. So no one is actually above or important in this container view. Okay, so this is what layout priority does. It helps you keep your views intact by asking other views to adjust their size to make room for that one view that you feel is important. It could be your brand name, customer information, customer name, because of course, in the app, you don't want to break like customer name into multiple lines. That'll look weird. So you may want to basically define the layout priority for those elements. Okay. Now this is also useful in cases when the text is truncated, and you can actually say that I don't want the text to be truncated. I want my text to always be visible on the screen. So for example, I can take the layout priority from this one, and I can actually reduce this and keep it like, dev.key width, and then I can actually say line limit 1. Okay, and if I do line limit 1, notice that learn iOS is replaced with ... Now let's go ahead and set the layout priority for this one as 1. Now what happens is, as soon as we define the layout priority for learn iOS width as 1, it is actually now became the most important view in this entire HStack container. That means it needs to be rendered properly, and render properly meaning it would render its own content, and everyone else will basically get the rest of the space which they can actually share and divide each other. So notice dev.key's E is now hanging on the 3rd line to make the room to display this content. All right, so this is basically done as best as possible by the system, but let's say if you have really long line and it cannot fit the screen, then eventually your text will be truncated. But you now understand how you can actually make your views a little bit above the normal priority by setting their layout priorities. And with that, we have reached the end of this video. Thanks again for watching, and I will see you guys in another video.